Great. Hi everyone, my name is Gigi Pavur and I'm an undergraduate senior at Georgia Tech majoring in Earth and Atmospheric Sciences. I'm so excited to be here today with you all at AGU to tell you about a project I did this summer through NASA Develop. So NASA Develop is a program within the Applied Sciences program at NASA, which is designed to increase participants like me our capacity to use NASA Earth observations. So we do 10-week feasibility projects. So with the help of my teammates, Chelsea Dandridge, Robin Kim, and Sarah Aldama, we were able to use NASA Earth observations to improve landslide situational awareness in the Dominican Republic. Next slide, please. And one. Okay, so imagine that we are 3,389 miles away from where you're sitting right now at AGU. You'll find a small country on the island of Hispaniola in the Caribbean Sea, the Dominican Republic. So with its location in the hurricane belt of the tropics, the Dominican Republic is frequently exposed to very heavy rainfall events, which can trigger landslides. So my developed team partnered with a geological service in the Dominican Republic to help improve their situational awareness of landslides. And our project partners were really interested in understanding how to limit the loss of life and protect infrastructure for landslides. And then also our project supported an international agreement between the NASA Earth Science Division and the Central American Integration System. And that agreement was designed to increase collaborations between NASA and Central American countries. So it was really exciting to get to work on a project of this international scale and caliber. And then also, I'd like to point out that I too went bananas when I saw that fruit also has landslide risk. So NASA has about 30 satellites that are constantly orbiting Earth and collecting environmental data. And this data is really useful to study environmental challenges like landslides. So for our project, we used 2 Earth observations. The first was from the Shuttle Radar Topography Mission, or SRTM, which provides elevation data, and we use that to determine slope. And then we also used global precipitation measurements from GPM, which is the satellite right here. Okay, so landslide experts at Goddard Research Center, Space Flight Research Center, created a model called LHSA. And yes, you guessed it, LHSA is another NASA acronym. So it stands for Landslide Hazard Assessment for Situational Awareness. So this model is publicly available online through GitHub as both a Python script and an R script. So my team worked to use this model and take it from a global scale and cater it specifically for the Dominican Republic. And we did this by incorporating local data from our project partners. So a really important component of the LHSA model is a susceptibility map. So this shows the landslide susceptibility in the Dominican Republic. And my team created this by using a fuzzy overlay model to determine the correlations between landslide factors like elevation, slope, distance to active fault lines, clay percentage, lithology, and forest cover loss. And so when this static map is combined in LHSA with precipitation measurements, next slide, please. It will output near real-time Nowcast. So when the historical rainfall exceeds the 95th percentile, it will issue a high hazard Nowcast if your susceptibility map says it's a very susceptible region to landslides. So since GPM rainfall data is available every 30 minutes, you could realistically make new outputs for this every half hour. So you might be wondering, landslides are a natural process for altering topography. So why are they considered a natural disaster? What makes them a natural disaster? And what I learned through this project is that it really becomes a natural disaster when it affects people. So once again, our project partners were really interested in knowing where landslides impact people. So we created this Bivariate Map, which depicts the intersection of landslide susceptibility and population. So the regions that you want to pay attention to are this deep red color up there, which represent high population and high landslide susceptibility. And now, fortunately, you'll see there aren't actually that many pixels of that color, which is a good thing. And then you can see as well that Santiago and Santo Domingo and then Barahona all have high populations because those are their main cities, but they aren't located in susceptible regions. This central area has very high landslide susceptibility, but not a lot of people living there because it's actually a national park. So the idea is that this bivariate map can be used for quick heuristic identifications of regions where people are at risk. All right, then lastly, a big final outcome of our project was we wanted to increase our project partners' capacity to actually use NASA Earth observations. So we wrote a tutorial so that they could do everything that we did over the summer. And one thing that we also showed them was how mapping landslides from space can help them better understand where landslides occur, even if they don't have the budget necessarily to do ground mapping or like field research. So the three images on the left, show an interesting story about a landslide that happened. So we have a forest with a road going through it in 2012, and then by 2016, all the trees are gone, and then by 2018, we have evidence of a landslide. So once again, our project partners can use this to go back and improve their historical landslide inventory. And then our tutorial also went through how to use LASA and how to make their own susceptibility map. And then lastly, it was translated into Spanish and shared with other Central American countries so that they can hopefully use this as a starting point to use LASA in their country. Okay. Oops. So I'd like to end with a quote that was in the NASA calendar last year, which, judging from the line over there, I'm sure you guys are all familiar with it. But the quote, I think it perfectly captures the value of applying NASA Earth observations to combat environmental challenges. So the quote is from Nelson Mandela, and it says, "Action without vision is only passing time. Vision with action is merely daydreaming, but vision with action can change the world." So quite literally, Earth observations give us the perspective and vision we need to take action. And according to Nelson Mandela, that's how we change the world. So here we can see the nightlights of Earth. And we know that from this perspective of space, disasters aren't confined by country borders. And from my Develop project this summer, I learned that the applications of Earth observations can also transcend these boundaries. Next slide. So lastly, thank you to the moon and back to all the people who helped me do this project, including our project partners in the Dominican Republic, our science advisors, Dr. Ross and Dr. Dahlia Kirschbaum, and then of course to my wonderful team, Sarah and Robin and Chelsea. They put up with a lot of landslide jokes from me, which, as you know, is a very slippery slope. Thank you.